Hey guys, welcome back to another video. Today we're going to be talking about topic 1.12, transformations of functions. An important aspect of understanding functions is the concept of transformations. Throughout this course, as well as past and future courses, we will study a variety of functions and their graphs. All of these functions can be viewed through the perspective of transformations. Transformations will weave through everything we learn in AP Precalculus, and they provide a way for us to connect the topics we learn throughout the course. Below is a table of transformations, along with how each transformation affects a graph. Let's start off with the vertical translations. Vertical translations are going to happen outside of the parentheses represented by the letter K, and it'll be shifted up or down exactly K units. So if it says +5, you're moving up 5. If it says down 3, you are moving down 3 units, okay? Horizontal translations are inside of the parentheses next to X, represented by the letter H. Everything that happens inside the parentheses is the opposite of what it appears. So if it says plus H, you're actually going negative H units. So if you think you're going to the left, you're actually going to the right and vice versa. Okay, for both of these transformations, the translations, you are going to do these by addition. So you're going to either add or subtract the number outside or inside, but both of them are going to be through addition. Okay, moving on to the dilations. So a vertical dilation has the letter A, and it is outside of the function f of x and is represented by the letter A, and it is exactly what it appears. So if you have, let's say 2 on the outside, then you have a vertical dilation by a factor of 2. So it's exactly what it appears, unlike the horizontal dilation where you have multiplication inside of the parentheses represented by the letter B, but this one, the factor will be the reciprocal, which is 1 over B. Okay, so remember that everything inside of the parentheses is not what it appears. So for dilations, you are going to be multiplying. So you can tell whether it's a dilation or a translation depending on if you're adding or multiplying that number onto the function. Okay, so back to the concept of reciprocals. Okay, so let's say this is 2, then the reciprocal of 2 is 1/2. Okay, if the reciprocal was 1 over 2, all you do for reciprocals is flip the fraction around. So instead of 1 over 2, you would have 2 over 1, and 2 over 1 equals 2. Okay, let's say it was 3 over 2, then it would be by a factor of 2/3. All you're doing is flipping the fraction around. That's the reciprocal. Okay, now we can also reflect over the x-axis and the y-axis. So for the x-axis reflection, you're going to have a negative outside of the function, outside of the parentheses. But if you're reflecting over the y-axis, that means the negative is inside the parentheses next to the x. Okay, now even though this 2 is, it looks like it's a negative 2, it is, but the negative is strictly for the reflection and the 2 is for the vertical dilation. Okay, a few important notes and tips on transformation. So again, any transformations that affect the x values will occur inside the parentheses with the x variable. Okay, and everything that affects the x values will do the opposite of what it looks like. Okay, so let's go back and look at the horizontal translations and the horizontal dilations. Notice that both of those happen inside of the parentheses. So you got the x plus h or you got the bx, but that is inside of the parentheses, or you can also have the negative x, the reflection. All of that is happening inside of the parentheses. Okay, so again, the opposite. So if you think it's plus h, it's actually negative h, and instead of b, it's the reciprocal 1 over b. So it's the opposite of what it looks like, and that only affects the x coordinates. Okay, then we have the transformations that affect the y values occur outside of the parentheses, and those values that affect the y values do exactly what it looks like. Okay, so we have the vertical translation and the vertical dilation. Notice that both of these, here is f of x, okay, that's happening outside. Here's f of x, and the a is happening on the outside. Same thing with the negative, it's on the outside of f of x. So everything that affects the y values, it's outside of the parentheses, outside of f of x. Okay, Let's start with example 1. Let g be a function that is a transformation of the function f such that g of x equals 2 times f of x minus 3 plus 1. Describe the transformations of the function f that result with the function g. Okay, so what I'm going to start off doing is going in order from left to right and figuring out what's happening. I see a 2. I see that it is outside of f of x, so I know that's going to be some kind of vertical transformation. Because the 2 is multiplied to f of x minus 3, multiplication implies that it's going to be a vertical dilation, okay? So this is a vertical dilation, and I know that it's going to be represented by the letter A, and everything that's vertical is always exactly what it appears, so that means that A is 2, okay? Then I have a negative 3 that is being subtracted. Okay, so I know that everything inside the parentheses is horizontal, and since it's being subtracted, it's going to be a horizontal translation. So I know that h is going to be, remember it's the opposite, so instead of negative 3, h is actually positive 3. And then outside of the parentheses, I have a plus 1. Everything outside of the parentheses is for vertical transformations. And because it's being added, I know it's going to be a translation. I know that vertical translations have the letter K, and everything outside of the parentheses is exactly what it appears, so K has to be 1. Okay, now this is a free response question, so we're going to write a sentence. The function f is vertically dilated by a factor of 2. It is horizontally translated to the right 3 units, because that was a positive 3, that means it's going to the right, and it was vertically translated up 1 unit, because it was a positive 1 is going up. Okay, let's try another one. Example 2, let n be a function that is a transformation of the function m such that n of x equals negative 4 times m of 2x. Describe the transformations of the function m that result with the function n. Okay, so the first thing I see is a negative. I know this negative is happening outside of the parentheses, so that's going to be a reflection over the x-axis. Next, I see this 4. That 4 is being multiplied outside of the parentheses, so I know that's going to be a vertical dilation, which is the letter A, and everything outside is always exactly what it appears, so that means A is 4. Next, I have 2. It is inside the parentheses, so I know it's going to be a horizontal transformation, and because it is being multiplied, I know it's a horizontal dilation. I know horizontal dilations are represented by the letter B. Remember that the factors for B are the reciprocal. Everything inside the parentheses is not what you think it is. So instead of 2, that means that B is 1/2. Okay, so let's write our answer. We're going to say the function M is reflected over the x-axis. It was vertically dilated by a factor of 4, and horizontally dilated by a factor of 1/2. Okay, let's go on to example 3. The graph of y equals f of x, consisting of 2 line segments and a semicircle, is shown above for -3 to 5. Sketch a graph of g on the same axes above, where g of x equals f of x plus 3 minus 4. Okay, so first let's figure out what the transformations are. I see something happening inside the parentheses, so I know it's going to be a horizontal transformation. Because it's being added, it has to be a horizontal translation. Okay, that means that h is -3. Remember, everything inside is the opposite. I have a -4 on the outside, Outside of the parentheses are your vertical transformations, and because it's being added or subtracted, it's a vertical translation, represented by the letter K, which is exactly what it appears. It is a -4. Okay, so this means we're going to the left 3 units and we're going down 4 units. But they didn't ask us to write the transformations, they said to sketch a new graph. Okay, so what I'm going to do for all these types of problems is create a table where I'm going to figure out what the new points are going to be. Okay, so in blue, I'm going to put all of the original coordinate points, and then I'm going to add what I need to do. Okay, so to the x value, since I'm going to the left 3, I'm going to need to subtract 3. And for the y values, I'm going to subtract 4. Okay, so remember the horizontal transformations, it was only this one, those affect your x coordinates, which is why I only put it on the values for x on my table. Okay, and everything that happens outside of the parentheses affects your y values, which is why I put it on this side of the table. Okay, so what I'm going to do now is find coordinate points. The first coordinate point I see is -3, +3. So I'm going to put -3, +3. The next point I see is 0 and 1. Next, there isn't an exact point inside the semicircle, but I'm going to make one up. Not make one up, I'm going to approximate one. Let's say 2 and 2.5. And then we have 3, 1, and we also have 5, 1. Okay, so I'm going to subtract 3 from all of these x values because all of the x values need to be shifted to the left 3 units. Okay, -3 minus 3 is -6, 0 minus 3 is -3, 2 minus 3 is -1, 3 minus 3 is 0, and 5 minus 3 is 2. Okay, now we'll subtract 4 from all of the y values. 3 minus 4 is -1. 1 minus 4 is -3. 2.5 minus 4 is -1.5. 1 minus 4 is -3, and 1 minus 4 is -3. So what I'm going to do now is plot these new points on my graph. So we have -6, -1, which is over here, -3, -3, -1, and -1.5. Oh, I think I did that wrong. That should have been, oh no, I didn't. -1, -1.5, 0, -3, and then 2, -3. Okay, now all that's left is just to connect your points. So I'm gonna draw this line here. This, like, that looks ugly, hold on. Something like this, and then the little last line segment. Okay, so that is this graph being shifted to the left 3 units and down 4 units. Let's do example 4. The graph of y equals h of x has a hole at x equals 4 and consists of 3 linear segments. Sketch a graph of k on the same axis above where k of x equals -h of 2x plus 1. Okay, so we're going to do the same thing here. We're going to figure out what the transformations are, and then we're going to make a table. So the first negative I see here, that's going to be a reflection over the x-axis. Sorry, my pen glitches sometimes. Next, I have this 2. It is happening inside of the parentheses, so I know it's going to be a horizontal dilation. Remember that inside is the reciprocal, so instead of 2, it'll be 1/2 for B. And then the K is 1, which is my vertical translation because it is outside of the parentheses. Okay, so I'm going to create a table now. So for my X values, remember, it's everything inside the parentheses, and the only thing we had inside the parentheses was a factor for the horizontal dilation. The factor was 1/2, and for dilations you multiply. So we're gonna do 1/2 times x. And then for the vertical, for the y values, it's everything outside of the parentheses. So we had a negative on the outside and we had a +1 on the outside. So I'm gonna do -y plus 1. So remember, I'm doing the original coordinate points in blue and I'm doing the transformations in pink. Okay, so I'm going to do 1/2 times, and I see my first coordinate at -4, -3. So 1/2 times -4, and then -3 plus 1. Okay, and then we're going to have another one, 1/2 times, I see my next coordinate. I'm really only doing the critical points. I don't need to spend time finding points inside the line, because if you have the two on the outsides, you're gonna just connect them. So you don't want to do all these in the middle. You can if you want to, but it would be a waste of time. Okay, so the next one I'm gonna pick is -2 and 1, and then plus 1. The next coordinate will be 1/2 times 0 and -2. Next, we have 1/2, and the last point is at 6, 4. Now, the only issue is that right here, we have two random points. We have one that's a whole and one that's by itself. So I'm going to need to transform those as well. So that means I'm going to have two more points here that I need to worry about. So the whole is at 4, 2. And that random point is at 4, -1. Okay, so what I'm going to do is label it. So when I regraph it, I need to make sure that they are still the same. Okay, so remember at 4, 2, we had a whole. And at 4, -1, we have a random point. Okay, so now let's simplify. So 1/2 times -4 is -2. 1/2 times -2 is -1. This is 0. This is 3. This is 2. And this is 2. Now, negative, -3, two negatives make a positive. So it's really 3 plus 1, which is 4. -1 plus 1 is 0. Those two negatives makes a positive. So 2 plus 1 is 3. -4 plus 1 is -3. -2 plus 1 is -1. And those two negatives make a positive. So 1 plus 1 is 2. Okay, so now let's go ahead and plot. We have -2, -2 and 4. -1, 0, 0, 3, 3, -3. Now remember at 2, -1, we said there would be a whole. So when I go to 2, -1, I'm going to make sure to make an open circle because that's my whole. And then at 2, +2, there was a random point. Okay, so now let's connect our lines. So we have this one here, this one, and then this one. Don't draw through your hole because it should stay open. And there is your new graph. Okay, let's do another example. Example 5, the domain of f from example 3 is -3 to 5, and the range of f is 1 to 3. Find the domain and range of g, where g of x equals 2 times f of x plus 3 minus 4. Okay, so what we're going to do is the same thing that we did earlier. We're going to write down all of our transformations. This 2 is going to represent a vertical dilation because it's on the outside of the parentheses and is being multiplied, so I know that A is 2. This 3 will be my horizontal translation, and I know that H will be -3 because inside the parentheses it's always the opposite. And then this will be my vertical translation because it's outside the parentheses, and outside is exactly what it looks like, so it's a -4. Okay, so I'm going to create a table, and I'm going to put my x values and my y values. So we have x. The only horizontal transformations are those inside the parentheses, which was minus 3. So I'm going to subtract 3 here. And then for the y values, we're multiplying by 2 because there was a vertical dilation of 2. I'm going to multiply my y values, and then I'm going to subtract 4 because the vertical translation was going down 4. Okay, now you're probably asking yourself, well, where are we getting points from? Good question. That comes from these values here. Okay, so we're only given the domain and the range. So this is going to be one of my x values and my second x value. And this is a y value and another y value. So these are going to go over here. So negative 3 and 5 for the x values. And then for the y values, we have 1 and 3. So the x values, I'm going to subtract 3 from them. All the y values, I'm going to multiply by 2 and subtract 4. And we're going to get a new domain and range. Okay. Negative 3 minus 3 is negative 6. 5 minus 3 is 2. 2 times 1 is 2, and 2 minus 4 is negative 2. 2 times 3 is 6. 6 minus 4 is positive 2. Okay, so now for the answer, we have the domain of G. Now the new domain is just going to be your x values because the domain is a set of x values, okay? So we have negative 6 to positive 2. And for the range of G, we had negative 2 to positive 2. Okay, now sometimes depending on what the transformation is, sometimes these might be out of order. For example, I could have a positive 2 and a negative 2. You would not say 2 to negative 2 because that is not from least to greatest. Remember, all of your intervals should always be from smallest to greatest. It should always be from left to right. So if that happens to you, like you write it down, let's say you had written this down, then that's up to you to realize you need to switch these around. Okay, so just keep that in mind. Example 6, the table above gives values for a function p at selected values of x. Let h of x equals 3 times p of 2x minus 1. Find the following values. A says find h of negative 1. Okay, so first I want you to realize that the table represents p of x and this function represents h of x. They want us to find h of negative 1. Okay, h is in the equation. So what I'm going to do is evaluate the function at negative 1, meaning all the x values I need to plug in a negative 1. So this will be equal to 3 times p of 2 times negative 1 minus 1. Okay, so just to show you, these two are the exact same thing. The only difference is that instead of x, we are evaluating at negative 1. Okay, the next step, according to PEMDAS, is parentheses. Inside the parentheses, I have to multiply 2 times negative 1, which is negative 2. Okay, now we have this, which is p of negative 2. Well, we have the table for p of x. So all they're saying is what is y when x is negative 2. When x is negative 2, the y value is 1. So what I can do is rewrite this as 3 times 1 minus 1. Okay, so again, p of negative 2 is 1. Okay, so when the x value was negative 2, the y value was 1. So now 3 times 1 is 3, and 3 minus 1 is 2. Let's try that again. H of 2. We are going to be plugging in 2 into the equation of h, which will be 3 times p of 2 times 2 minus 1. So again, we're just replacing x. We're plugging in 2. According to PEMDAS, we're going to multiply 2 times 2 first, which is 4. From here, we need to figure out what is p of 4. Okay, p of 4, you're going to look at your table, find where x is 4, and that y value is 3. So now we have 3 times 3 minus 1. And 3 times 3 is 9, and 9 minus 1 is 8. Okay, let's try again. So you're going to plug in 0 now. So we have 3 times p times 2 times 0 minus 1. We're going to do the parentheses first. 2 times 0 is 0. Now we need to figure out what is p of 0. So we're going to go to the table. When x is 0, y is negative 1. So we're going to do 3 times negative 1 minus 1. 3 times negative 1 is negative 3, and negative 3 minus 1 is negative 4. Okay. All right, let's go on to example 7. The function g is constructed by applying 3 transformations to the graph of f in this order. A horizontal dilation by a factor of 3, a vertical dilation by a factor of 4, and a vertical translation by negative 7 units. If g of x equals a times f of bx plus c, find the values of a, b, and c. Okay, so first let's look at this. Remember that a represents your vertical dilation is outside of the parentheses and is being multiplied. Whatever is inside the parentheses is your horizontal transformations, and because it's multiplied, I know it's a horizontal dilation. What's on the outside represents your vertical stuff, and because it's being added, it has to be a vertical translation. Okay, so now let's go in order. We're gonna say A, B, and C. All right, the first thing says a horizontal dilation by a factor of 3. But remember that everything inside is always the opposite, and for dilation specifically, it's the reciprocal. So if I were to make this 3 into a fraction, it would be 3 over 1, so the reciprocal would be 1/3. Okay? The next thing, a vertical dilation by a factor of 4. I know that let me be more accurate. A vertical transformation is always what it appears to be. So if it says a factor of 4, then a is equal to 4. And same thing with the vertical translation, it'll be exactly negative 7. Okay, so that one is pretty easy. Let's move on. Example 8, the table above gives values for a function h at selected values of x. Let k of x equal a times h of bx plus c, where a, b, and c are positive constants. In the xy plane, the graph of k is constructed by applying 3 transformations to the graph of h in this order. A horizontal dilation by a factor of 1/2, a vertical dilation by a factor of 3, and a vertical translation by 1 unit. Find the value of k of negative 6. Okay, so the first thing we need to do is figure out what is a, b, and c. Okay, so remember that a is your vertical dilation, b is your horizontal dilation, and c is your vertical translation. So if I'm reading the transformations, they said a horizontal dilation would be b. But remember that b is the reciprocal, so instead of 1/2, we have 2. Vertical dilation is a, and it's exactly what it appears, so a is 3. And then finally, the vertical translation would be c, which is also exactly what it appears, so c has to be 1. So if I plug those into the formula, then I would get that k of x is equal to 3 times h of 2x plus 1. Okay, so again, all I did was plug these numbers into the formula to get this one. Now, the next thing that they want us to do is figure out what is k of negative 6. So all I need to do is plug in k of negative 6, just like we did on the previous example. So I'm going to plug in negative 6 everywhere that I originally had an x. Okay, and that's to solve the actual question, k of negative 6. We had did parentheses earlier. That's the first step, so 2 times negative 6 is negative 12. Okay, now we have this random h of negative 12. We were given the table for h, so all I need to do is find where x is negative 12 and the y value there is 1. So I can rewrite this as 3 times 1 plus 1. 3 times 1 is 3, 3 plus 1 is 4. Example 9 and the last example of today. The function p is given by p of x equals 3x minus 2. The graph of r is the image of the graph of p after a horizontal translation of 4 to the graph of p. If r of x equals ax plus b, find the values of a and b. Okay, so what we're going to do, they said that there is a horizontal translation. Well, I know that that is letter H. And if it's a horizontal translation of 4, then that means H is 4. So I'm going to do R of X is equal to P. Horizontal translations are inside the parentheses. So if I want to move this over, it'll be negative 4. Okay, now that's all they said. That's the only transformation that happened. If there were more transformations, for example, if they said and a reflection over the x-axis, then I would do negative p of x minus 4. If they had also said and it goes up 3 units, then I would say plus 3. But those would occur outside of the parentheses, okay? If they had also said and a horizontal dilation of 1/2, then I would put a 1/2 out here in the front. So this one looks pretty simple, but it's because that's all they gave us to do. All they said was we're going to the right 4 units, okay? So what I'm going to do is similar to what we did in the other one, which is that we're going to plug in x minus 4 into these x's here. Now, it looks more complicated, but it's the same process as up here. Just that instead of plugging in a singular number, we are going to be plugging in an expression. We're going to be plugging in x minus 4. Okay, so we're going to have 3 times x minus 4 minus 2. Okay, so let me just show you this. I want you to see that these two are the exact same thing. The only difference is that instead of x, we are replacing that with x minus 4 to represent the horizontal translation of 4. So we're going to the right 4 units. Now, to simplify this, I need to distribute this 3 in here, which will give me 3x minus 12, and then I still have the minus 2. If I combine like terms, I would get 3x minus 14. Okay, now remember this was the equation for r of x. They also told us that r of x would be equal to ax plus b. And they said, what is a and what is b? Well, a is being multiplied by x in the equation, and we have 3. And then b is what is added at the end. We have negative 14. So a has to be 3 and b has to be negative 14. Okay, and that is the end of these notes. I hope that it made sense. If you have any comments or questions, please leave them down in the comments below. I will see you guys in the next video. Bye.